Hello and welcome to the Remaining Sane, Finding Peace in Our Chaos podcast, a podcast about both theology and police work. I'm your host, Will. In today's episode, I interview Dr. G. Dr. G, how are you?
I'm doing good. How are you doing?
Good. For those of us that don't know Dr. G, you have a pretty long and complicated name for us English speakers to put out. So you're actually Dr. Guilaran. Would you mind talking just a little bit about who you are, where you're from, what you currently do now?
Sure. Yeah. So my full name is Ildefonso Hollandoni Guilaran II because I'm half Filipino. So I got that name from my dad, but I was born in the 70s. And so a show called Happy Days was really popular. And my mom asked her class, what should I call him? And they're like, duh, Fonzie. So I often go by Fonzie Guilaran, and then in an academic setting, a lot of people just call me Dr. G for short. So that's everything for today about my name. I am originally from Kentucky, from Western Kentucky. Went to Western Kentucky University for college. Met my wife there. Went to grad school at Florida State University for a master's and PhD in experimental condensed matter physics, which is really just kind of like material science. Worked at I was a professor at a college in Indiana for 4 years after that. And then for the last about 15 and a quarter years, I've been at Union University in Jackson, Tennessee. And that's where I met our host here.
And one of the things that you do at Union is you are part of a class that is known as Creation, where you talk about how science and faith interact with one another. And is that correct?
Yeah, that's part of what it does. It does a lot more than that, but that's a major piece of what we try to do in there.
And one of the things that I had brought up at one of the previous episodes is the double slit experiment. And I pretty poorly tried to explain what the double slit experiment was and then its theological implications. And so I wanted to have someone on that is maybe a little bit more acquainted with the science in and of itself, more than I am, to really explain some of the nitty gritty behind the double slit experiment, but who also has a Christian theological background to talk about its theological implications and what we can glean from that. And so, Dr. Guilaran, why don't you take it away? Would you mind explaining to us what the double slit experiment was, when it happened, and some of the stuff that we've learned from it?
Okay, so there was, if you go back at least as far as, let's say, Democritus in ancient Greece, I think came up with the concept of the atom, like the smallest, building block of what we might now call the physical universe. So things were made or imagined to be made up of particles. Even way back then, I know there were a lot of hypothetical schemes, I guess, by the ancient Greeks, that they dreamed up. But at least we can trace, the concept of the atom, at least back as far as that. And fast forward, and let's say we're considering the notion of light in particular. So that physical thing or substance that comes into your eye and you're able to see things, right? So we're thinking about light in particular. And fast forward all the way to the 19th century, mid-19th century, with James Clerk Maxwell, and he unifies all magnetic and electrical phenomena under the so-called four Maxwell's equations. And using Maxwell's equations, you can mathematically model light, and it's clearly a wave. Okay. And so you've got this sort of competing notion then for light as say a particle, like imagine photographic film that's very, very lightly exposed or something. You might see little spots on it, right, instead of a whole picture like looks grainy. So you can imagine the light being particles. Okay. But from maybe low exposure photographic film, or even if you just sort of close your eyes and you can see little spots, little sparkly spots, where you might have some little particles of light hitting your retina or something like that. But then in the 19th century, as I said, in terms of the mathematical model, you can, the way to define that is like the way that we imagine what's physically happening through the math, like the mathematical objects we use to model the phenomena. That's what I mean by a mathematical model. It's how we're imagining the thing that we're investigating. And so you have these equations that are equations for waves, and that's what is given to you by Maxwell's equations, specifically to model light. Now it's easy to imagine a particle because you've made like a snowball, or you can break off a little piece of something and toss it or flick it or whatever. So we don't have a lot of trouble understanding, or sort of everyday like non-physicsy people don't have any trouble imagining particles. But waves, on the other hand, have a very specific meaning or definition that's a little bit different for physicists than maybe the layperson. And that extends as far as, if you know anything about trigonometry and sines and cosines, sines and cosine functions, trigonometric functions, like that's the mathematical object. But if I could draw it, it would be like, a wiggly thing going across, going across the screen, like a wave, like ocean waves or something like that. That's what we mean by waves. And so if Maxwell's equations essentially said that light is a wave, the very cheapest experiment that you can do to prove to yourself that light is indeed a wave is you can take two adjacent fingers, say your middle finger and forefinger on one hand, and put them together, but leave a little bitty slit between them, and then take and look through that little bitty slit at a light source, okay, like a bright light or even a lit up wall. And then with your other hand, push your two fingers together until that slit is almost gone. And if you do that, you will see that there are little dark lines running in the slit parallel to the edges of your fingers. And hopefully those aren't hairs or anything weird like that. That'd be really strange. But rather those are where the light is interfering with itself. And in fact, the dark lines are where the light is destructively interfering with itself. It's canceling itself out. Okay, just like if you've been to the ocean or a big lake and you have waves coming in from different directions, sometimes when those waves come together, they make bigger waves, and that's called constructive interference of waves. And then sometimes they cancel each other out, and that's called destructive interference. And so the dark lines between your fingers in the slit, that's where the light is canceling itself out. And particles don't cancel themselves out. Only waves cancel themselves out. Okay, so that little two-finger experiment, that you can do for free, is a clear demonstration that light is a wave. And so then if you fast forward just a little bit more, from mid-19th century to 1905, Einstein publishes some major papers in that year, one of which is on the so-called photoelectric effect, and never mind what that's all about. But essentially, he explains an unexplained problem in physics by saying that the light is actually behaving as a particle, and that the word for that is a photon. a light particle being called a photon. And so with that paper and the work of some other early 20th century physicists, the pendulum swung backwards from light being a wave, but also strangely being a particle. But yet, both sides were well founded on experimental evidence. And so after the early 20th century, scientists were forced into the strange conclusion that light is both a wave and a particle somehow at the same time. And it's not, it turns out, only light. It is in the 1920s, Louis de Broglie would put forth the hypothesis that it's not just light, but it's all mass energy. So even things like protons and electrons and even entire atoms have this strange wave particle existence.
And so that's true, right? Like, not only does light itself have that kind of like duality, but also you're saying that like everything essentially has that, but to certain different degrees, correct?
Well, it's not even to differing degrees; it's the same degree, and when we say all things, so we need to be careful there. So we can say all physical things, or actually, we might not even go that as far as that. We might say all mass energy, because I can't confidently say if I include other things like space and time. I don't know that we have a wave particle theory of space and time, but I can at least say all mass energy. So, which includes a lot of the physical, just not maybe all the physical. And we certainly don't want to include the spiritual, right? When we say all things. So I want to restrict, I want to, when we say all things, I'll restrict, to just physical things. And even inside the physical things, I would restrict it to all mass energy.
Okay.
So that includes, though, the mass energy you're made of. So your protons and electrons and atoms and molecules and all those things that physically make you up, and me and everybody else, and the walls and the buildings and the air, that, yes, they all, to the same degree as we understand it from 20th century physics, they all have this crazy wave particle dual nature.
That's pretty mind-boggling when you look at it, right? Like I don't think most people can look at themselves and say, "Hey, I'm a wave." That is pretty.
Unless they're breakdancing, right?
Yeah. Are you saying also that at certain times light is a particle in this moment and it's a wave in this moment, or are they both? Is light both a particle and a wave fully at the same time?
So we need to get into a little bit of epistemology, or how do we know? Because it's essentially, I think, maybe what you're asking is, how do we know it's a wave in one instance, and how do we know it's a particle in another instance? All science is empirical, so that just simply means to gain scientific knowledge, we have to measure things, and we know through the measuring of things. And so essentially the upshot is, if we set up an experiment to know a certain thing or things, and we can set up one experiment, and that the results of that experiment will show light or mass energy to be a wave. And then we can set up another experiment, a different experiment, and if we set that experiment up, then it'll show itself to be a particle. And so it kind of depends upon the experiment that you set up, but the upshot is it appears, I mean, to the best of our ability, it appears to be somehow at its root both of these things, and it expresses its particle-like nature in some experiments, and it expresses its wave-like nature in other experiments. But because these two natures are obviously contradictory, because a particle is zero dimensional. It has no length, width, or height. It's all and it's all it's this little bitty thing that's infinitesimally small. It's concentrated at one point in space, as opposed to a wave, like a sine wave or a cosine wave, something like that. It's spread out, even infinitely in either direction. So it doesn't have a well-defined position, you could say. So like these two natures appear to contradict each other. Like how can this one thing have both of these natures? That's really weird. So that's but again, that relies on sort of a physicist notion of what a wave is, a very mathematically well-defined notion of what a wave is. Yeah.
And so I assume that inherently makes it extremely hard to deduce down light itself, right? Like, it's got these two competing natures to it, and you can't say that it is 100% one way or 100% the other way, but rather it's both ways.
Well, it's just like I think like the light detectors in the retina of the human eye, I think are sensitive enough. At least I've read that they're sensitive enough to even detect a single photon. So like if you close your eyes, you're still getting a little bit of light, maybe through your parts of your eyelid. I don't know. I'm not exactly sure what those signals are, but like you've probably imagined like opening your eyes in a really, really dark room and you still see little spots. I remember a high school friend, saying when he closed his eyes, he could still see little dots all over the place, right? So those little dots, if that's a single photon, if you close your eyes and you see those little dots, then perhaps you're running an experiment and of what light is, and boom, there it is. It's showing itself to be a particle, a little dot or something like that. And then the two finger slit experiment that I described earlier, there you're doing an experiment and light shows itself to be a wave. And so you can have these two kinds of experiments and with a much bigger budget and with a lot more precision, and these two natures show up one or the other in various experiments that are really just kind of more complicated versions of maybe what I've described.
Yeah. And in your class you talk about the theological implications of this also. And on a personal note, one of the things that I mentioned in one of the previous podcasts is that this really had a somewhat profound effect on me, learning that even in the natural world, there are truths that almost express themselves that Christians, have known for 2,000 years. And then, namely, what screams out to me is the deity of Christ, because Christians have always taught that God is fully man and he is fully God, or rather, Jesus is fully man and fully God. And what this shows is that light has that same two natures about it, right? Like, and you can't just say one and forget the other. Yeah, I think that's just really profound, because and I also think that it's profound that we as humans inherently have a hard time understanding one thing having two natures at the same time. That's kind of something that like you can say, but it's really, really hard to wrap around your brain. Do you have any more thoughts about that?
Yeah. So possibly the most influential passage of scripture on my physics and science teaching, the last decade and a half, has been it's Romans 1:20, Romans chapter 1 verse 20, and I'll read the NASB 1995 version of it here. It says, quote, "For since the creation of the world, his," that is God's, "invisible attributes, his eternal power and divine nature, have been clearly seen, being understood through what has been made, so that they are without excuse." End quote. So what Romans 1:20 says is essentially saying is that God has written bits of himself into what he has created. That is, it says, we might catch a glimpse of his invisible attributes, his eternal power and divine nature. We might catch a glimpse of those in looking at what he has made. And because it says that they've been clearly seen, being understood through what has been made, is what the verse says. And so when I came to Union University, this was one of the formative passages, because I asked the question, well, if that's true, physics, is one of the scientific disciplines that studies, what Christians call the creation, and so maybe by studying physics, we might catch a glimpse of God's eternal power and divine nature. And so with that verse, sort of giving us that particular disposition, then I started looking for, are there physics specific ways in which this happens? Because there are other scientific disciplines, obviously, like the life sciences, biology, chemistry, physics, geology. I mean, there are other scientific disciplines, but are there glimpses of God via Romans 1:20 that maybe are specific to physics? And when I taught on in various courses this 20th century physics topic of wave particle duality, when you teach on that, students tend to have it's like there's a tension, right? There's a tension in trying to imagine a proton or electron. It's easy to imagine them as particles, like the atom is the planetary model of the atom, like the electron is going around the proton in hydrogen, let's say, that has one electron and one proton in it. They're going around each other, kind of like the Earth goes around the sun, like a planetary model. But even then, you're imagining them as particles, right? You're not imagining them as waves. And so it becomes, much more difficult to imagine electrons and protons and even atoms as waves and particles at the same time. It's like these are two contradictory natures. And so I would teach, this topic. The tension would build. You're spending weeks of class time, teaching on these ideas and the various mathematical models they involve, and then in a non-Christian setting, you kind of just have to leave the students there with that tension, and they're just like, how can it be like this? And you have even Richard Feynman, one of the greatest physicists of the 20th century, saying, how can it be like this, right? And that's where they're left. But where I teach at the university I teach at, I'm able to go further, and it's only after that tension has sort of set in, for even a few weeks, that I end with a certain theological point, where I involve Romans 1:20, okay, saying, hey, maybe we'll catch a glimpse, of God, by studying even the physics of the really small, and then I also say, well, okay, what is a part of God's eternal power and more specifically divine nature, right? We know that, as you said, Jesus is fully man and fully God, but man is sinful and has to die, finite, I guess, at least in a certain sense, physically has to die. Whereas God is holy and pure and without sin, and not dependent on time as man is. And there are so many other differences. And so how is it that Jesus could be both fully man and fully God, right? It's there's a tension there, right? And there's such a great tension there that the the early church in the Roman Empire even had a council, the Chalcedonian council, in which they tried to work out how is it how is it that Jesus was fully man and fully God. And they I don't know the history of that exactly. I do know enough to know that they found it leads to heresy if you go too far in either direction. And so they were stuck with the strange conclusion that he is fully God and fully man at the same time, if you will. And they wrote the Chalcedonian Confession. And I have this Chalcedonian Confession here, which I can pull up. Or actually, it's the Christological definition from the Council of Chalcedon. And this is 451 AD. And part of it reads, I'll go ahead and read it, this part. One and the same Christ, Son, Lord, only begotten, recognized in two natures, without confusion, without change, without division, without separation. The distinction of natures being in no way annulled by the union, but rather the characteristics of each nature being preserved and coming together to form one person in subsistence, not as parted or separated into two persons, but one and the same Son and only begotten God, the Word, Lord Jesus Christ. Okay, end quote. So they're trying to write down precisely what it is they believe, but there's still plenty of mystery, right? They still say, that Jesus is, one and the same, recognized in two natures, without confusion, without change, without division, without separation, right? I lead students, this far, that far into the semester, and then I go ahead and make the connection. And here's a very strange way to make it, but it'll get my point across. And this is going to sound really heretical at first, maybe, but it'll get my point across. I'm going to replace references to Jesus with wave particle. And I want you to hear how strangely modern it sounds. Okay, so I'm going to read the same stretch of the Christological definition from 451 AD, but I'm going to insert wave particle as in the wave particle duality of all mass energy. So one and the same wave particle, recognized in two natures, without confusion, without change, without division, without separation. The distinction of natures being in no way annulled by the union, but rather the characteristics of each nature being preserved and coming together to form one wave particle, not as parted or separated into a wave and a particle, but one and the same wave particle. So that sounds really heretical, but I can very easily insert wave particle in here for where Jesus is referenced, and it sounds like it came out of 20th century physics, right? So that
and it's neat that you can look back 1600 years and they're coming across the same, it almost the same new modern definition, like as you said, if you were to change the noun there. But by no means do they have any technological capabilities at all of doing the light. They're doing the wave particle light experiment, but they're able to come to the same conclusion about something, about Christ. And how what's neat here is, as you study the world around you, there are, as you said, there are ways in which God reveals himself, and that by studying the world, in some ways you can study God. And then also going the other way, there, as you study theology and you study God, it does help you understand the world around you, because it's not like God has just removed himself from the world. Like these two things do interact. There is a God, right?
And so to connect the dots completely, what I'm asserting here is that the wave particle duality of all mass energy, as we understand it, in the 21st century, is a direct manifestation of Romans 1:20. That's what I'm suggesting here, in which the divine nature is expressed in what God has made. In this case, the physical creation. And in particular, it's this strange mystery of how can these two natures how be present in Jesus Christ, and that particular mystery is manifest in all mass energy, in the wave particle duality of all mass energy, which also has seemingly two natures that seem contradictory, but are, as our experiments tell us, are present simultaneously without annulling each other in all mass energy, right? And so this is one of multiple, I believe, direct manifestations of Romans 1:20 in physics. And I also tell my students, the non-Christian, right, when they study modern physics and wave particle duality, they have to just stop where Feynman stopped and just wonder at, like, wow, how can this be? The experiments tell us it's like this, but how can it possibly be like this, right? That's where a non-Christian education has to stop. But in a Christian setting, we can actually go further. That is, we can say, well, it's actually like this because Romans 1:20 tells us that God has written bits of himself into what he has made, so that we can catch glimpses of him by studying, what he's made. And so usually the pop culture, I guess, paints the Christian as the idiot, right, in the corner, but it's the secular person that can go further. But it turns out here it's the Christian that can go further in their understanding, and well outpace obviously the secular person or the atheist, right?
And along those lines, this is kind of a secondary question, but how has being a Christian, while also simultaneously being a scientist or a physicist, I assume you've had to reconcile with that a lot. Like you've had to, especially in today's modern culture, where you get told a lot, oh, you can't do your job seriously and also be a Christian. How have you dealt with hearing that kind of criticism, and then also reflecting upon that?
Well, I will say that that particular aspect of a career in science, it depends on what area of science you're in terms of the level of hostility that you get. So, for example, in what I've discovered in life science and in biology, there are biologists out there that simply say that you can't be a biologist and be a Christian. It's extremely hostile, I guess, for a religious person being first and foremost religious, and then a biologist. And if you want to look up more on this, you can look up Todd Wood, for example. Is a very interesting young Earth creationist who is also an extremely well-trained biologist, and there have been online posts by other biologists saying he's not really a biologist because of his young Earth position. That's just to say that it depends on which area of science you're in. And for me in particular, I understand why Todd Wood holds to a young Earth position. I don't think Genesis requires a young Earth position, so I would be an old Earther. But nevertheless, he's an example of a scientist who is literally rejected by some of his peers, and his work rejected just because of his religious views. But in physics, it's not nearly as it's not as hostile, I guess I could say, as I've come to find that it is in life science. That is, no one's gonna. I was never said you can't get your PhD because you're a Christian or something like that, right? So, and I've never heard any testimonies to that effect. But nevertheless, right, if you follow Jesus, then your identity first and foremost is in him, and so you're not going to want to be two separate persons. That is, you're not going to want to divide your professional life from your religious life, but rather like you want to be a whole person, and you're going to look for how do these two things come together, right? I don't want to compartmentalize these things. And so, but in many colleges and universities, you're not really given the freedom to explore that. Or if you're going to explore it, you need to do it certainly on your own time,
with your own money.
and don't tell anybody, or you'll get fired. And so I'm blessed to be at a university where not only have the freedom to do that, but I even have the freedom to do that and share with students, what the things I discover. And so, I've not found, some great impasse, between physics and Christianity that I've not, found peace with or anything like that. Right. It hasn't destroyed my faith or anything to that effect. In fact, it's just the opposite. It's, as I learn more, it builds my faith up.
Yeah. Yeah. Well, thank God. It's a very good thing. Well, my final question for you, as we're getting to the top of the hour here, is do you have any final counsel or advice that you would like to give to the audience? I know we haven't touched much on police work really at all, but it's really taken this much time to really explain and flesh out the experiment and the greater christological implications here. But would you mind just giving a brief advice, counsel, something you would like to leave the audience with?
I know very little about police work. And I'm super happy that God has called his children into, every nook and cranny of modern society. And in the case of your host, calling him into a career of police work, that is awesome. Right. You can be a light, wherever he calls you. I would say, look for, just generally speaking, I've been able to find in physics, I've been able to find that physics is a stepping stone to worship. That is, I can take like this notion of wave particle duality and lift it up as an offering to the Lord, and as a fragrant aroma, right? This understanding, and in that way, it can be a stepping stone to worship. And it would be really cool to know how this can happen in every profession and every discipline and so on. Like how does the particular practitioner that follows Jesus Christ, how do they offer up their work and their labor and everything that comes with it? How do they offer that up as a stepping stone to worship? But the belief that there is a way and ways to do that, and it's just a matter of revelation of God revealing them to you. That's that belief, must be there, or you won't be looking for it, right? So make sure that belief is in place, and then share with others, what you found, how your work and your labors are indeed stepping stone to worship.
Well, Dr. Guilaran, thank you so much for coming on the podcast. Remember, if you have any questions, feel free to fill out the Google form that's attached in the description below. And if you want to reach out to the podcast, you can find us on Twitter @RemainingSanePC. Have a blessed rest of your day.